page I am at, 7 of 12.
Yeah.
You know, in defining motion, you need to take note of certain symbols. We use U. I can start with S. This is motion and motion graphs. Are you listening?
Yes.
There are certain symbols we use. S stands for what? T stands for what? U stands for what? V stands for what? A stands for what? S stands for what?
S stands for speed.
Not speed. S stands for distance or displacement. Okay?
T stands for time.
By the way, displacement is distance in a specified direction. Displacement is a vector quantity. Distance is a scalar quantity, okay?
Okay.
You know what are vector quantities, by the way?
Vector quantities are quantities that have direction.
Vector quantities have both magnitude and direction. When you are defining it, you have to include they have both magnitude, which is size, and direction. Scalar quantities have only magnitude, which is size, okay?
Okay.
So you can use S to represent distance or displacement, T for time, U for what?
Initial velocity. Yes.
Initial velocity, yes. Or you can even use it to represent speed. By the way, velocity is speed measured in a specified direction. So velocity is a vector quantity, while speed is a scalar. Speed is just magnitude without direction. Velocity has both magnitude and direction. V stands for final velocity, okay?
Yeah.
Or final speed, if you like. A stands for acceleration, of course. Isn't it?
Yeah.
Okay. I need to remind you of the equations of motion very, very quickly. You know the usual simple formula for speed. How do we calculate speed?
Speed is distance over time.
Yeah, speed is distance over time. I zoom in. So what symbol do we use for speed?
Symbol for speed. V.
U or V, right?
U or V. Yeah.
Which could be initial or final speed. It's equal to distance over time. So S will be here, time will be here. Is it not?
Yeah.
So U or V is distance over time. Make S the solid formula. Or how do you find distance from this formula?
Okay, distance is speed over time.
Okay, just a moment, please. Are you still there?
Yeah.
How do we find distance?
Distance is speed over time. I mean, distance is speed over time.
Speed over time. Are you sure?
Yeah.
In this kind of formula, how will you find distance? We use this formula triangle.
Speed over. Oh, sorry. Speed times time.
Speed times time. So distance S is equal to U or V times T, right?
Yeah.
You only use this formula when speed is constant. Let me explain it to you. Please pay attention.
Okay.
Alright. So when speed is constant, you use this. That's when speed is not changing. What formula do you use when speed is constant?
When speed is constant,
To find distance, what formula do you use?
speed times time.
Now, when speed is not constant, and for all cases, when speed is not constant, let me write it with a different color, which should be all cases, including when speed is constant. When speed is not constant, and in all cases. And for all cases. When speed is not constant, and for all cases, this is the formula you should use. Are you ready for that?
Yeah.
Now, distance, instead of saying v times t, you use average speed times time. You use what?
Average speed times time.
Distance will be average speed
What?
times time. Pay attention, let me explain it. Because speed is not constant, that's why you're going to use this different formula. When speed is not constant, okay? Did you hear me?
Yeah.
For instance, in your class, everybody is not of the same age. Am I right?
Everybody is not on what?
Of the same age in your class. Is everybody of the same age?
No.
But we can find the average age. How do we find the average age?
You add all of our age together, then divide it by the number of
Students.
divided by how many we are.
Divided by the number of students in your class, or how many you are. So when speed is not constant, like speed is not the same, just like when all of you do not have the same age, we have to use average speed times time. We are not just going to say speed times time. We use what? Average speed times time. Can you get the difference?
Yeah.
If speed was constant, we just say speed times time. But if it's not constant, we use average speed times time. Now, there are two different speeds here, u and v. So what will be its average?
The average.
Yes. For two different speeds, u and v, what will be its average?
So I don't get it.
Yes, of course. You know how to find average now.
Yes, I not find average.
How do you find average?
Average is the number.
So if you have two different speeds, just like in your class, you have different people with different ages. This time around, you have two different speeds, u and v. How do you find the average? Average of this speed.
Yeah.
Are you listening?
Yes.
Okay, so how do you find the average? There are two different speeds, u and v. How will you find the average?
Okay, you add them and divide by 2.
Good. So, if that is the case, the formula for distance will now be equal to S equal to, the average is u plus v. You said we add them, which is u plus v, and we divide by 2, is it not?
Yes.
That is for the average speed, though, before we multiply by time. Before we multiply by time, by t. Is that clear?
Yes.
So the formula for distance is average speed times time, which is u plus v over 2 times t. We got it from this table, this formula triangle. Remember, the formula triangle is basically speed equal distance is equal to speed times time. You know, S stands for distance. Remember when I told you that S stands for distance or displacement? T for time, U for initial speed or velocity, V for final speed or velocity, A for acceleration. So from the formula triangle, distance is equal to speed times time. You can use that when speed is constant, but when speed is not constant, you do average speed times time, which is U plus V over 2 times time. In fact, use this one in all cases, you will not make a mistake. But if you use this one when speed is not constant, you will make a mistake. I hope that's clear.
Yes, sir.
Now, what is our acceleration?
Acceleration is. Should I say the equation?
Or the definition?
So what is it?
You can say the definition.
Oh, acceleration is the time rate.
Of change of velocity.
The rate of change of velocity.
So, can you give me the formula now?
Yeah, acceleration equals to U plus V over time.
Are you serious? You see, that's why you need to understand the definition so that you don't state the formula wrongly. It's about change. When you're talking about change, what do? If you bought something for 80 naira and then you paid 100 naira, what would be your change?
200.
Please listen very attentively. I said you bought something for
20.
You bought something for 80 naira and you paid 100 naira, what would be your change?
20.
How did you come about that?
You minus 100 by.
So change is about subtraction, okay?
Oh,
So acceleration, and whenever we say rate has to do with over time. Rate has to do with what? Over
over.
time. So it means acceleration should be equal to rate of change of velocity, which is final minus initial, divided by time. Did you see that?
Yeah.
So what's the formula for acceleration again? Give it to me.
Acceleration equals initial velocity.
No, what does it?
Final velocity. Final velocity minus initial velocity over time.
Okay. Final velocity minus initial velocity over time gives you acceleration, okay? Is that clear?
Yes, sir.
All right. Don't forget that speed itself is distance over time. Is it not?
Yeah.
Let me just state some of these things here. Speed is distance over time. So we can define velocity as displacement over time. Displacement over time. Over time, okay? Because I told you that both distance and displacement are about change in position. They will use the same unit, S. But displacement is distance in a specified direction. Did you get that?
Yeah.
So it's a vector quantity. Displacement is a vector quantity. Because it's distance in a specified direction. Displacement is distance in a specified direction. So when we are, and you know, speed and velocity are also talking about the same thing. Velocity is speed in a specified direction. So since speed is distance over time, distance, so over time for speed, because no direction is needed. Velocity, which has to do with direction, will now be displacement over time. Displacement over time, because this direction is displacement. Direction is distance in a specified direction. So velocity is what? Read the formula I'm saying.
Velocity is displacement over time.
Speed is what?
Speed is distance over time.
Formula for acceleration. Or define acceleration.
Acceleration is the rate of change of velocity.
You can include the time rate of change of velocity. What's the formula?
The formula is acceleration equals to final velocity minus initial velocity over time.
Okay, that's correct. Another way you can write this formula is to say this, or we can write it like this. If you make V the Shelton formula, right, you're going to have V equal to U plus AT. V equal to what?
U plus 8.
V is equal to U plus 80. Just make V the formula, you will get this. V equal to U plus 80.
So you can find velocity a different way.
Yes, you can find the final velocity. V stands for final velocity now, is it not?
Yeah. Oh.
Yes. Okay. Let me zoom it out so that you can have all of this in one space. So I want to talk about them. Now, the other formulas we can use, I will just state the other formulas. It can be derived, but let me just state them. Other formulas are, you can also have V squared equal to U squared plus 2AS. Have you come across it?
Plus what? 2AS.
What does A stand for?
A is acceleration.
S stand for what?
Distance.
Okay, you can also have S equal to UT plus half AT squared. I've already given you the other ones. I've given you the first, these two. This one. These ones I wrote in yellow. Let me even call them equation 1 and 2. Equations 1, equation 2. Then I can call this one equation 3 and equation 4. Okay?
Yeah.
These 4 equations of motion. Or I can just say other equations. Other equations of motion. Other equations of motion. Okay. See, when you want to use this equation, you look for the quantities given. Okay?
Yes.
And then what you are looking for. For instance, I'm going to give you a question that will test this. Just a moment. Okay. Like a question like this. Example. I hope you're paying attention.
Yeah.
A car starts from rest and accelerates at 5 meters per second squared for 10 seconds. Find the final velocity. Read it out. Go ahead and read it out. Did you hear what I said?
Okay, sir.
Read it out.
A car starts from rest and accelerates at 5.
5 meters per second squared for 10 seconds.
No.
Find the final velocity. Okay?
Oh, okay. A car starts from rest and accelerates at 5 meters per second squared
For 10
for
seconds.
10 seconds.
Find the
Find the final velocity.
Okay, so how do we do that? Look at the equations of motion.
So-
Which one can we use?
So,
Go to the-
final velocity
Go to the previous page and see the equations of motion.
is not hard. Final velocity equals acceleration plus wait. Oh, it's initial velocity
Which equation are you using? Which equation are you trying to use?
plus
Go to the previous page.
acceleration.
Go to the previous page and tell me the equation you're
times
trying to
second.
use.
Yes, times time.
Go to the previous page and tell me the equation you're trying to use. So which equation are you trying to use?
Sir, your voice is cracking.
Okay.
Oh, I'm trying to use this one.
Okay. So which equation are you trying to use? Name the equation. 1, 2, 3, or 4. Which
Two.
you want to use equation 2? Okay, let's go. You can use equation 2.
Yeah, I'm just figuring out how to find initial velocity.
Good. I like that. By the way, before we
Okay,
use
that's from your rest.
it start say that again.
It starts from the rest.
Start from rest. That means initial velocity is what?
0.
Good. So note. Good note. When we say from rest, let me even write it down. A, from rest means u equal to 0, right?
Yep.
To rest, B, to rest means it came to rest, means final velocity is equal to 0. Do you understand?
Yeah.
Or you can say 0 meter per second. 0 meter per second. Now, if we say fall, free fall, under gravity without air resistance. Free fall without air resistance. Acceleration is equal to positive g, which is 10 meter, approximately 10 meter per second squared, or you can use 9.81 meter per second squared. So if they can tell you that something falls freely, just use acceleration as 10 meter per second squared or 9.81. Okay?
Yeah.
If you are told that something rises, that's D, rise under gravity. This one is rise under gravity. This is also free fall under gravity. Rise under gravity in this case, acceleration is equal to minus g, which is approximately minus 10. minus 10 meter per second squared, or you can say minus 9.81 meter per second squared. You need to take note of all this because sometimes the question is not clearly going to state all these values, but you will just hear from rest like this one, or to rest, which means v is equal to 0 for to rest, or falls from a point. When it's falling, that means acceleration is 10 or 9.81 meter per second squared. Okay?
Okay.
Or if you are told that it rises, you use acceleration as minus g because it's going to decelerate. Now finally, if it rises to maximum height, rise to maximum height. Let me just add that. If it rises to maximum height, it means final velocity is 0, which is v. Final velocity is what?
0.
V is 0 because it's at maximum height. It has to stop first before it falls back. You know, when you throw an object up, it has to rise to a point and stop before it falls back. So final velocity at that point where it stops, the maximum height is 0. Okay?
Okay.
So from
Can I go into that?
okay. While you're doing that, let me quickly give you a few questions to illustrate this. Let me write another one. This one says an object falls from rest at a height of 20 meters. Ignoring air resistance, find the maximum speed. Just before it hits the ground. It reaches the ground. Let me give you yet another one. A stone is thrown vertically upward. Vertically upward. That's another example. The train is thrown vertically upward with an initial speed, or with a speed of, let me just say with a speed of, with a speed of 25 meters per second. Find a the okay, I'm writing out a few questions so that we can just read them together. Find the maximum height. Okay, maybe I should give you the time taken to get to the maximum height. For the stone to reach its maximum height. So you also find V, its maximum height, the maximum height. Let's look at all these questions, one after the other. Go to the previous page, starting with this first example. I'll just call them example 1, example 2, example 3. Let's start with example 1.
Okay.
Example 1 says a car starts from rest and accelerates at 5 meters per second squared for 10 seconds. Find the final velocity. So which equation are you going to use? Equation 1, equation 2, equation 3, or equation 4? Equation 2. Okay, because equation 2 has some of the things we need. So from equation 2, this is the answer to this. From that solution, let's call it solution here. From equation 2,
The answer, according to my calculations, is 50.
okay, what did you do? You did V equal to
No, first,
U plus
I
80.
multiplied the acceleration by the time.
Because U is
And
U,
since the
U is what?
U is 0,
Why
since
is
it's from rest.
because it's from rest. Because we say from rest means initial velocity is 0. So we simply say 0 plus A, acceleration is 5 times T 10. So V is this. And that will give us V equal to 50 meter per second, okay? Are you getting that? By the way, I need to add that the unit of distance is meter, SI unit is meter. Let me indicate that. SI unit of distance is meter, SI unit of time is seconds, SI unit of speed is meter per second, final speed of the same thing, meter per second, SI unit of acceleration is meter per second squared. So all of these things must be in their SI unit, otherwise you have to convert them to SI unit before you can work with them. Are you listening?
Yeah.
Go to the next page. Let's do number 2. It says an object falls from rest at a height of 20 meters. Ignoring it.
My laptop is lagging. It's not sending it to me.
Okay. Just hold on. It will send you to 2. So,
Okay, I'm on the next page.
okay. Alright, so it says, ignoring the air resistance, find the maximum speed just before it reaches the ground. An object falls from rest at a height of 20 meters. It falls from what?
From rest.
So what's the initial speed?
The initial stage is 0.
So U is 0. You see, when that kind of question is given you just need to know what quantity you are already provided with, even though they didn't state it clearly like that. So initial speed is 0 and the height of 20 meters. So what that other thing? That's the distance now, is it not?
Yeah.
So S is 20. What other thing is stated? Ignoring air resistance, find the maximum speed before it reaches the ground. Maximum speed is the final speed now, which is v. That's what we're looking for, is it not?
Yeah. So we can use the same thing.
Let's check. And then we are also told that it falls. It does what?
It what?
The object falls from rest, falls freely. And I told you about when something falls, go to the previous page. C. Note C.
Oh, free fall.
Free fall, acceleration is what?
10.
So that means acceleration is already given as 10 meters per second squared. So let's see the formula that we can use. A formula that has these ones plus what you are looking for. Go to the previous page and look for any formula, all the 4 formulas. Equation 1, equation 2, equation 3, equation 4.
Question 2.
Are you sure equation 2 we do the work?
Wait, maybe like question 3.
Let's see equation 2. V equal to u plus 80. Do we have time? We don't have time, so we can't use equation 2.
We can use question. We can use question 3.
We can use equation 3. V squared equal to u squared plus 2as, right?
Yeah.
Let me write it down. V squared equal to u squared plus 2s. There might be another equation we can use, but let's quickly use this one. V squared equal to u squared plus 2s. We are asked to find the maximum speed, which is that v, is it not?
Yeah.
Okay, so v squared is equal to, what's the u squared?
V squared is
0 now, 0 squared
0, 0.
plus 2as, 2 times 10 times s, which is 20. 2 times
So that
400, I think.
4.
So v squared is 400. So what's v?
So 400 cubed. 400 cubed.
Did you say cube?
I mean 400 squared.
Do you mean square root?
That's square root of 400. That's 20.
So v is 20 meters per second. Okay. Let's look at example number 3.
A stone is thrown vertically upwards with a speed of 25 meters per second. Find A, the time taken for the stone to reach its maximum height, and B, the maximum height.
Okay. Let me just list all the things that we need here. We can solve all this in this page. I'll just zoom it in. A stone is thrown vertically upward with a speed of this. It starts with a speed of this, right?
Yeah.
So this is the initial speed. Let me just write it on top of it. This is u. Okay? That's u. Did you get that?
Yeah.
And it is thrown vertically upwards. What other information can we derive? Go to the page 7 of 14. No, it's not. It's 8 of 14. We talked about it. Page 8 of 14. Rise under gravity. What did we say?
Minus 10.
Minus 10. So the acceleration, it means we have the acceleration as minus 10. So A is equal to minus 10 because it's rising. Do you understand?
Yeah.
U is 25 meters per second. A is minus 10 meters per second squared. What other thing is provided?
Vertically upward.
Okay. When you throw something vertically upward, it will get to a point and it will stop. where it reaches its maximum height. So still go back to that page. Read E. What does I say about E?
E rises to maximum height.
When
V
it
equals to 0.
when it reaches maximum height, V is equal to 0. So that means we already have V. So since it rises, it means V is equal to 0, okay?
Yeah.
So we have this now. Let's now find the time. What can you do? What equation can you use to find time for A? Question A. Are you trying to figure out the equation you can use to find the time? Let's go to the equations. Page 7 of 14. Which one can we use? Equation 1, equation 2, 3, or 4?
We're trying to find maximum.
We want to find the find time first. We want to look for the time.
Time. Okay, we can use the last one.
We can use the last one, yes. S equal to no. Where we
Or
can
maybe you can use the first one. You can find what's good. Make it the subject or something.
Is the distance given?
Distance.
S is not given, so we can use the first one.
We can use the second one.
We can use the second one. V equal to U plus 80. Yes. V equal to U plus 80. The second one is V equal to U plus 80, right? We can use it. So let me write it down. V equal to U plus 80, right?
Yeah.
So V equal to U plus 80. Let's put the values. What's V?
V is
We've already obtained the values now. Just substitute them. V is what?
okay. V is 0.
How did we come about the 0? Because at maximum height speed is 0, is it not?
Yeah.
So I will say 0 is equal to U. What's U?
U is 25
Plus.
plus the
What's A?
A is minus 10.
Minus 10 times T, is it not?
Yeah.
So when you cross over, you have 10T. You can solve that equation now. 10T is equal to 25, is it not?
Yeah.
Let me zoom it in a bit.
So the answer is 2.5.
Yes. This is minus 10 here. So T is equal to 25 over 10, which is 2.5 seconds. Okay?
Yeah.
Let's look at the second part of the question. It says find the maximum height. Maximum height is about what now?
Maximum height is about
Distance.
where you reached.
That's distance now, is it not?
Distance, yeah, distance.
What equation can we use?
This for distance. Distance is S. So we can use last one. We can use the last one.
We can use the last one. We can even use this third one. Or the last one. Even the first one, Seth. Because we found time. Any one that has
Oh,
S,
yeah, we can use the first one. The first one is easier.
we can use the first one. So S is equal to U plus 8. S equal to U plus V all over 2. So this is question A. Question B now. Let's use the first one. S equal to U plus V over 2 times T, right?
Yeah.
What is U? What is V?
U is 25.
25 plus 0 for V over 2, then times T, since we found T, 2.5. So what will it give us?
20.
That will give us 12.5 times 2.5.
The answer is 31.25.
31 point. Let's make it 3 meters. That's the SI unit, isn't it?
Yeah.
Okay, just take note of all that we've done. You know how to apply the formulas.